Okay, good morning, pilot teachers and students, and good morning, class.
Good morning, Mr.
You may sit down. All right, our topic for discuss today will be on kinetic energy. That is what we will look at this morning. Now, before we go on to looking at the kinetic energy itself, can you define kinetic energy? Who's going to give us the explanation? Okay, let's have Jos.
Kinetic energy is the energy a body has because of its motion.
Okay, good. The kinetic energy is simply the energy that body has by virtue of its motion, or if it is in motion, then it possesses some kind of kinetic energy. Now, before we go into looking at this kinetic energy, all right, we know that work is the measure of amount of energy being used. But how is work related to this kinetic energy? Right, if you can look up, I have the equation now, which will illustrate, or let's say, how that kinetic energy has been derived from work. Now, we know that when a force is applied to an object, it must move through a distance in order for that work done. And given from the equation of motion, which is v square equals to u square plus TAS. Now, for this, velocity square is the final velocity that motion will have. And that u is simply the initial velocity. What is the starting velocity? If it was at rest, then initial velocity would be, what would be the initial velocity, John?
0.
Okay, 0. Good. It's going to be 0 if it was at rest, because there is no velocity. Now, this is two different points, okay, before and after that motion has to start. And acceleration is simply the change in velocity every time, or we can simply say it is a measure of speed every second. And as for the distance that object has moved. Now, if we have to derive this, how is this equation, kinetic energy equals to half mv squared? How did we derive that equation? Simply, we have to look at the first one. Work equals to force times distance. And then, where does force come from? It is from the mass and acceleration. All right, in here is an acceleration. How do we find this A? Okay, simply A equals to v squared minus u squared over 2s. So we have to put that in. Work equals to force, which is for mass, times this acceleration given. A equals to v squared minus u squared divided by 2s. And then we derive that further. Work equals to, okay, that is acceleration, that is a mass, and we supposed to have one s here, this s. Okay, this s and s will have to cancel out. Okay, so we are left with work equals to m v squared minus u squared over 2. Right, since this was this initial object was at rest, okay, before it moved, so that means velocity will be 0. Final minus 0 will be always the final answer. So we have only one as mv squared over 2. That is why we can simply say work equals to force times distance, and it is also equal to the kinetic energy, which is given by this formula as half mv squared. Okay. So with that, I'll go through and give you the definition and some notes before I give you your activity questions. All right, this is a definition. Kinetic energy is the energy that body will possess because of its motion. Okay, moving on to the next slide. It can also be the work that is done by the body in losing its motion to come to a rest. Okay, again, kinetic energy is also the work done in that, or for that body to lose its motion to come to rest. Okay, moving on. Okay, that is the equation. As you can see, for the body of mass m moving with the speed v, right, the kinetic energy can be calculated using the formula as given below, half mv squared. All right. You should have finished by now. We'll move on. Okay, next. All right, from there you will find that the body is moving in a given direction with speed u, increases its speed to v after moving a distance. So we find that any object, for example a car, when it is moving, sometimes increases its speed. That is why If you want to calculate the work done, then it is the work done final after the work done initial, meaning that half mv square final can minus the initial half mv squared to give you the amount of work that is done between those 2 points. Just a foot. 5 and 6. Okay. Here are the last of those two. Okay. The equation that is given earlier in the last slide is simply the work energy theorem, meaning that there is a change in work that is done. So from this equation, you can find that the work done is of that moving out object, okay, from an initial position to the final is equal to the change in kinetic energy of that object. So you can find that the kinetic energy of these changes. Okay. All right. This will be your last information, and then from there I will ask you to go through and then do the activity questions. Right, if the work done is positive, the kinetic energy increases. If the work done is negative, okay, energy will decrease. If the energy decreases, the work done is negative work. Now, if you can remember from our last lesson, I did explain to you exactly how and why negative and positive work is done. Okay, it depends on some other forces which are either opposing that motion, thus creating or giving us a work which is either positive or negative. All right, here are your questions, activity questions. Please to go through and then copy those questions quickly. And for the first, the body of mass 10 kilogram, it started from rest and then it's accelerated or accelerate through a distance. If you have the final velocity, which is 20 meters per second, what will be its kinetic energy? Question 1, 2. You will do question 1 and she will do question 2. Right. Activity question number 2. Okay, this should be question number 2. Okay, this time it is asking you to calculate the mass of the body if you have a velocity which is 10 meters per second and the kinetic energy was 40 joules. Question number 3A. Not this one. Question 1, 2, you will do 3A. Okay, here is question number 3. That question has 4 parts to it. Okay, third question. There are 4 parts to this question. Question 3 says or reads body of a mass which is 8 kilogram, and then is moved through 10 meters with an acceleration of 6 meters per second square. Okay. Question number 1 is what will be the force acting? Okay. Question 3, 3A. Yes, will be 3B. Okay, quickly copy the question. Finish copying. Okay. B, C, and D. B is how much work is done by the force. C, if the mass starts from rest, what is the velocity of the 10 meters? And D is what is the kinetic energy after 10 meters? So those are the 4 questions to question 3.
So this is the last question.
I think so. Okay, you can now work on those questions. There are only 3 questions. Question number 3 has 4 parts to it, and you can see B, C, and D. Thank you. Okay, question number 1, question 1, 2, 3A. You willing to do one question? Are you willing to do correction to one question? Okay. 3A, 1, 2, 3A. 3B and Solomon, 3C, and we'll have someone else. And you do the last one. Okay, 3D. Okay. B, C, D. Okay, I'll give you a few minutes to work on those questions. All right, pilot students, if you have any difficulties with those, you can also ask your teacher to help you with those questions. And it is similar to you, more students. If you have any questions in regard to those activities, please raise your hand so that you can get some help. Okay, let me see question number 1. Yeah. Okay. Okay. You finish? Wait. Which one? Which one is it? If a body of 8 kilograms is moved with acceleration, what do you know about the acceleration? What is the force acting? How do you calculate the force? How do you work out the force? Force equals to what equation? There is no work done. From this you can use any one of those values to calculate. So in here force will be given. There is no distance. There is no. But what is the unit actual equation or formula that you will use to calculate the force? Huh? How do you find force? If in this case the force, how do you calculate the force? Force times mass times acceleration. Okay, is the mass given? Yeah. And acceleration. Okay. You finished with question number 1? Any questions? Three A. B? No, not you. I was thinking that you will finish. Oh, you will not do anything. It's you. Okay, there. Okay, you will do 3A. All right, we shall go through and then have a look at the answers to those questions. Okay, I will ask the first person to get ready. I'll tell you to move to the front and then you. Yeah, if the mass starts from rest.
So if the work done is 4 million joules.
Which one is this? What is the work done after 10
What
meters?
is the velocity?
Yeah, it's using the work energy theorem. Okay, what is the final work done? What is the initial work done? And then you get, yeah,
Use the same
yeah,
formula after.
yeah. In here you can find that there too. Because it starts from rest, that is why you will use Ke equals to half mu squared because it is initial. If it is final, then K equals to half m v squared. And then you minus them. Okay, final minus the initial to give you the amount of work done. So because it was at rest, you know that velocity will be 0 for initial. So that means it is 0. You get the final minus the 0 will give you always the final. Okay?
This minus from this.
Yeah. This one minus 0 will give you this figure.
Since I minus from 0 to
Yeah. This one will minus 0.
480 minus 0.
Yeah.
It will be 480.
It will give you 480. All right. We shall now have the first question. Okay, Rachel is going to show us the answer to question number 1. Can you rub that, use this marker? That's right. You want to find the velocity, then you have to use that formula out there. You are not given the kinetic energy.
Since the question is asking us to find the kinetic energy, use the formula half times mass times velocity squared. And the mass of the object is 10 kilograms times the velocity squared, which is 20 squared. And you get half of 4,000, which is 2,000 joules.
All right, hands up those students who got that answer. Okay, you are correct. So, moral students, pilot students, if you have something like that, that is the answer to the first question. All right, let's have question number 2. Which one? Acceleration. It is the change in speed every second. Yeah, yeah. Let me see your question. How did you? Okay. Question 1. Which question is this? A. Yeah. Work equals to. It is asking you to find the force. Force equals to mass times acceleration. What is the mass? 8. What is acceleration? So the answer will be 48 newtons. Okay.
Question asks us to find the mass, so I transposed the formula to make m the
That's right.
subject. So mass is equal to 2 times the kinetic energy over the velocity squared. So that's 2 times 40 on 10 squared, which is 80 on 100, which equals to 0.8 kilograms.
Okay, answer to the question 0.8. Hands up those who have 0.8. Okay, we have 0.8. Very good. That is the answer to Question 2. Okay, moving on to question 3A.
Since the question is asking us for the force acting, yeah, force is equal to mass times acceleration, which is 8 times 6, which is 48 kilotons.
Okay, if we have force which is equals to mass times acceleration, if we have put that correctly into those that formula, you will have 8 times 6, and that will be 48 newtons. That is correct. Okay, 3B.
To get the work done by the force, we use the formula
do you have in the
work
next
equals to
lesson? What do you have?
mass times
Maths, chemistry.
acceleration times distance. So which is mass is the 8 and acceleration is 6 times distance 10. We'll get 480 joules.
For B is 480 joules. Do we have something like that? Correct. Okay, moving on to question, part C of question 3. What is your answer to that question? You just use that equation k equals to mv squared, and then you use the square root of that too.
Given by the formula, work equals half times mass times velocity squared. Since the work amount of work done is 480 joules, 480 equals half times the mass, which is 8 kilograms. You rearrange that, 480 divided by half divided by 8 would give you 120, which is equal to v squared. Square root of 120 gives you 10.95, which is the velocity.
Okay, those students have hands up if you have answer like this. Okay, very good. That is correct. If you have 10.95 meters per second, that is the speed or velocity of that object. Why? Because when you calculate it, the work is given as 480 joules. So putting into this equation as kinetic energy equals to half mv squared, you can now find the velocity, and that will be 10.95 meters per second. Okay, we'll have the answer to last question.
Using the formula for kinetic energy, half times mv squared, I got half times 8 times the square of 10.9, and the answer 479.61.
479, which is almost equal to 480. All right, this can be either 480 joule. Okay, why? Because if you have to calculate, the final work will be equals to half v square minus half u square. All right, in this you have that as half times mass, which would be, what is the mass? 8 times minus times 8 times. Why? Because it started from rest, and that is why we had to come up with this. It will be 0. So that 480 minus 0 will be 480. So after 10 meters, all right, the same, or let's say 480 meters of joule of work has been done. Okay. So that is the answer to the last question. Right, please check your answers out. Pilot students, if you have any questions or difficulties in regard to these questions, you can also seek help from your teacher. And also, if you have any other things that you further need to know, always go through and then do some research in order to understand kinetic energy more better. Okay. In our next lesson, we will study the potential energy of an object. Okay, so these are the answers. You can also cross-check with what is there, and then give a mark out of 6. All right, our key phrase will be kinetic energy. Good afternoon, pilot teachers and students, and good afternoon, model class. Okay. Thank you. You may sit down.